Over the next few weeks, we're going to look at Newton's first and second laws. We're going to start off with the first one. So this is Newton's first law. And it simply states that if the forces on an object are balanced, then the object will do one of two things. It will either remain at rest, or if it was moving, it will travel at a constant speed in a straight line. Now, this is a very important law in physics. Let's look at some examples. It's probably the best way to explain this. So it says, if the forces of an object are balanced, what we mean by that is the resultant force is zero, i.e. all the forces cancel out. So an example, if we had an object and there was 10 newtons this way, for it to be balanced, there must be 10 newtons in the other way. So that's what we mean when we say forces in an object are balanced. Another way of saying that is just the resultant force, the overall force in the object, has to be zero. And then the object will do one of two things. If it was stationary, so for instance, if I have a book that's sitting on a desk, so there's my book, there are forces that act on that book. There's a force downwards, which is its weight, but because it's resting on a solid surface, there's a reaction force upwards, and when your book's stationary, those are both equal to each other. So let's say my book has a weight of 10 newtons. This would be 10 newtons. The overall force would be zero. And if my book was sitting there stationary, not doing anything, it will continue to do so. Okay. However, let's say I have a car and there is a 2000 Newton force from the engine forwards, but friction and air resistance are 2000 newtons backwards. Those forces are balanced as well. Okay, so the resultant force there is zero. The car can be doing one of two things. If it was stationary, it would stay stationary, but this car could also be moving. So if it was traveling at, say, a speed of, I don't know, 25 miles per hour, what that car will do with those two forces on it is it will continue to do that. It doesn't all of a sudden stop because the resultant force is zero. What it will do is it will continue to stay at that constant speed in a straight line. Okay, so we'll just, essentially Newton's law is, first law is, if the resultant force is zero, the object keeps doing what it was doing. Okay, so if it was stationary, it stays stationary, and if it was moving at a particular speed, it will continue to move that particular speed in exactly the same direction that it was going. Now, that works the other way then as well, that if the resultant force is zero, if the forces are balanced, then it must do those two things. But the other side of that is, if it is doing one of those two things, the forces must be balanced. So for instance, let's say I have a car, and I know that the engine is producing 1200 newtons of thrust forwards. And I'm told it's traveling at 50 miles per hour in this direction constantly. Okay, it's not getting faster, it's not slowing down, and I need to work out what friction or drag is here. Well, I know that if something is traveling at a constant velocity, it doesn't matter that's 50, but as long as that's not changing, then Newton's first law tells us that the forces must be balanced. Because if there was a bigger forwards force, it would speed up. If there was a smaller forwards force, it would slow down. But if they're balanced, then it just stays at that same speed. So if we're told something is traveling at constant speed in a straight line, the forces must be balanced on it. Likewise, if we're told something is stationary, so let's say we have a book on a desk, let's go back to that one, and we're told that the force downwards is, the weight is 20 newtons, and we're asked what is the reaction force upwards. Well, it's stationary, therefore Newton's first law applies, so the forces must be balanced, which means this force here must be 20 newtons to make those forces balance.